academic research in mathematical biology started, but the other is coevolution and evolutionary computation, a subset of solutions in machine learning. These days, I find the demands of my business clients often mean that I'm providing services that go beyond either. And I should point out that because I can't see either the chat window or requests for questions while I'm presenting this, it would probably be a good idea if you write the questions into the chat and I have a look at them at the end, because I don't know if people are putting their hands up for questions in between. So what sort of services am I providing through Co-Evolve IT? I've put them into 4 boxes, relatively related to the sizes of demand that I've seen. Thus, the largest is to do with data, by which I mean data science and data analytics. And you've seen that there a screen capture from our studio, and that's why you also see the Python project and R project icons above it, because they're the tool sets that I tend to use. I started off as a data analyst using R, but these days I would regard Python as more appropriate. Moving over to the right, an intermediate sized box is about algorithms, because of course data goes into a lot of machine learning algorithms, and it's not just a question of looking at that data in identifying how reliable they are, or indeed there's other questions you may want to ask. There's only a few shown there, but as a trained IT project manager, I think there's a lot of other questions that are worthwhile looking at, and I can also review your project to see whether it's producing a software product or service that is reliable. On the right-hand side, I'm showing smaller boxes, but they're relevant to a lot of projects, gaining funding through funding bids. I've had a successful track record in that area, and building collaborations that may be useful to projects. And I'll talk about that later. What sort of experience have I got backing up this service? I've had a long career in business R&D, working for other companies, not my own, including these 2 large telecommunications companies shown here. I've worked in a lot of different academic institutions. On the far right of the box on the right-hand side, labeled academia, you can see a number of institutions where I gained a number of skills which were transferable into business, and then later into other academic institutions where I was helping businesses. And the institutions shown on the left-hand side of the academic box are ones where I was supporting businesses from inside academia. And some of that support came through institutions that facilitated partnership, as shown in the partnership box in the center. At the top, UK organisations, and these were not the only UK organisations I have been dealing with. And at the bottom, the European Commission through a variety of different European calls, and the bottom right, a German funding scheme that I worked on while I was working in Germany. In addition, close to the present, I have been working not commercially, but as a volunteer with the UK NHS through the Analyst X scheme, and I'll talk a bit more about that later on. So I'll move on to talk about a very wide range of applications of mathematics and computing. There's clearly no time to take in everything in this table, but that's why I'm going to go through the talk and talk in more detail about things that I show in this table. So first of all, I'll go right back to my applied biological research, because this is where my interest in mathematics and computing came from, along with a lot of the skills that I was able to apply in business later. So where did it come from originally? Well, originally from an interest in understanding evolutionary biology using mathematics, and that's why you see the young Charles Darwin on the left-hand side of this slide. And you may be a bit surprised by the image in the center of the slide, because this is the Red Queen along with Alice through the looking glass. the red queen was a character that had to keep running to stay in the same place. And this may seem a bit surprising, but as I explain the images on the right-hand side, it will become less so. On the top of the right-hand side, you see a food web, a image of the feeding relationships in an ecosystem mapped as a mathematical graph. You don't see any detail about the species involved, except each species is a node in that graph, and each feeding relationship is a link in that graph. And species that are higher level predators are closer to the center, and species that are lower level prey are further out. But you can see that it's quite complicated. And initially, the idea in my mathematical biology doctoral research was that I would study something as complicated as you find in real life. But then I discovered that the computational resources available at that time were not sufficient to support such a study. So I focused on the interaction between a particular prey species and a particular predator, and what would happen not just when the predator ate some of the prey, and as a result the numbers of the prey species went down and the numbers of the predator species went up, but what would happen over evolutionary time if mutants were able to invade that allowed the predator to become a more effective predator, but at the same time mutant prey individuals to invade that allowed the prey to defend itself more effectively. And that's what the diagram on the bottom right shows graphically. If you represent the prey on the horizontal axis through a value that represents how effective a prey it is, and on the vertical axis a value that represents how effective the predator is. Now, of course, ideally, both the prey and the predator would like to get as far up as possible, but they're being pushed down by each other. So in fact, there's an evolutionary optimum right in the middle of this diagram, but neither the predator or the prey can reach it. In fact, they circle around it continuously, and that's why there's a loop in the middle. And that's also why I referred to the red queen in the image in the center, because there is this continual cycling. And where does this come from? I'll show you briefly the differential equations which represent it. Normally, the feeding relationships between predators and prey are reviewed by two different differential equations, which are called the Lotka-Volterra equations. But if we provide rules, as shown on the right-hand side, which indicate how mutants can invade, then we have to introduce two new differential equations and modify the original differential equations. And we actually have four different differential equations to solve. And if we solve these equations, we get something like the diagram showed on the previous slide. And in fact, when we think more about the genetics of evolutionary change, it becomes more complicated. But to summarize things, that's what I'm showing you there. That was a purely theoretical study in my doctoral research and immediate postdoctoral research, but I've also worked on mathematical biology applied in the field, specifically applied in an isolated and remote archipelago, the St Kilda archipelago, off the northwest of Scotland. And this is a harsh environment for semi-wild animals. These are Surrey sheep, because the weather can be very harsh and there's not much in the way to stop the North Atlantic battering this archipelago. The ram that you see on the photo in the center looks like it's in a very pleasant environment, but that's because I took it on a nice day, and it's not like that every day. And I call these animals semi-wild because many years ago they were managed by people living on the archipelago, but the Scottish government evacuated all the citizens living there in 1930 because they were finding it very difficult to continue living. but they left the sheep behind. Somehow the sheep survived, and in 1950 a long-term study began, which I joined in the 1990s. And through a combination of field data, statistical analysis, predictive modeling, and a mathematical technique called dynamical optimization, I was brought in to try and predict evolutionary change in these animals. So on the next slide, I'll talk about what we were actually trying to do. Well, I was trying to understand the survival, and considering we're thinking a lot about survival of people these days, of very non-human animals, in this case female animals, female sheep, because they're the ones that give birth to the new lambs, of course, through a state-dependent model where the states were aspects of choices that a female sheep could take. And this was parameterized using field data from the past annual census that was taken by going out in the field on the archipelago and studying the sheep. But these censuses were taken every year back into the 1950s. So I used the previous year's field data to generate transition variables between the states. And then once I had those transition variables, I parameterized what was known as a dynamic programming model. That sounds like it should be something that you can only solve using a computer. In fact, we did use a computer because we wanted to solve it quickly, but the mathematician who invented the technique of dynamic programming didn't in fact like computers as they were available at the time, because they were much larger and slower. And the reason he coined it dynamic programming, I don't know, but it's really a mathematical optimization technique that is independent of software development. We use computers to get the solution fast. And did it work? Well, having identified the parameters that female sheep should use in the future, we identified through dynamic programming that they should optimize their mass and their age to adapt feature reproduction. And looking as we were available to in future censuses, we found that yes, it did seem to work. Now, following that, I was looking for a new job, and oddly enough, I discovered that a large telecoms company was looking for biologists to study telecoms networks as if they were biological networks. You may well ask, is evolutionary mathematical biology a good basis for studying telecommunications, especially using computing in telecommunications? Well, I think it is, because I had been using mathematics, I've been using software development, I've been studying networks, and of course in telecommunications there's a lot of networks. I've been using dynamical systems, I've been studying evolutionary change, and I've been studying self-organization. And telecoms networks are certainly not stable. They are very dynamic, and if you refer to researchers such as Fabricant, who published this research shown at the back in 2003, he studied the ability to build overlay networks through self-organization such that clients can access this overlay network at one point, but through self-organization in that network, services can be delivered at one exit node and they can get all their results. And another biologically inspired solution, which has become particularly important in recent times, is the use of artificial neural networks, shown on the diagram in the front by FNN, which refers to feed-forward neural networks, here used in a transformer architecture published this year to apply to natural language processing, a very important area today, which I couldn't really have anticipated from the way computing was used in telecoms when I started in the late 90s. But self-organizing networks were of a lot of interest because we my colleagues and another company working with us in telecommunications had the view that if we could bring together clusters of similar nodes in overlay networks, this would be beneficial because we would expect more demand between users at similar nodes than between users of dissimilar nodes. And we knew that network creation games could facilitate the aggregation of such clusters and contribute to self-organized network design in this way. And you can see how this can work with a randomized network on the left-hand side on the right, and the use of network creation games to create tightly clustered nodes on the right-hand side. And you can see on the bottom left how this can create 3 aggregation clusters of similar nodes, less linked, but still linked together, so that if there is demand that goes across the networks, they can be connected. And this was presented at a conference on self-organizing systems, not just referring to telecoms, but it turned out to be useful in telecommunications, both for our employers and for another company. Another very biologically inspired area that we worked on well before the current very relevant focus on natural immune systems was artificial immune systems. We knew before we started working on artificial immune systems that natural immune systems appeared to be very flexible and adaptable, and that some of our colleagues in other organizations had worked on applications in areas such as computer security. In thinking about how to effectively design adaptable telecommunications networks, we were aware that there were problems that we could design a very adaptable network if we made every node in that network generalizable to respond to every possible request that could arise. But we would then expect to see some waste because not every node would be being used all the time to respond to all those requests. Alternatively, we could specialize every node a lot, but there would be some overheads as we distributed demands across the network so that a client who was making a request at a particular node could get it supported on different nodes. We found in building an artificial immune system to respond to this that we could get services located in the right place. We could balance loads across a network if they were requested in a dissimilar manner, and indeed we could potentially support faults if a particular node failed and other nodes had to respond. And because this was very related to real networks in its inspiration, it was presented at a conference on artificial life, and it led to an application for a patent in several domains where we as employees had to cede the ownership of the patent to our then employers, BT. Now, of course, real telecommunications networks don't look anything like this. Imagine that we have a network that has only 5 nodes, and each node is represented by a pie chart. This is nothing at all like a real network, but each pie chart in this network is producing only one service which has a particular color, and there's so few clients addressing this network that the requests made at each node are shown by only one color. You can see that one node, which is providing green services, is providing the correct service for that node because it's only receiving green requests. You can see that the other nodes in this 5-node network are getting dissimilar requests than what is requested by their clients. Now, this is where the artificial immune system comes in. You can't see it operating on the left-hand side, but what's happening as a user makes a request, it's stimulating a generation of an antigen, which is nothing like a natural antigen, but the antigen is stimulating the generation of T cells, which in turn will generate the stimuluses on B cells. And in due course, if a pattern of stimulus of T cells and B cells operates sufficiently within a particular node, we'll get activation of B cells to what are called in our artificial immune system fully activated B cells, and this will lead to a generation of a stimulus saying deliver a response to the client, and with the generation of the response the client will be satisfied. On the right hand side you can see a simulation which was done with more cells, and where you can't see the antigens and T cells, or indeed the antibodies that are generating the responses. You can see the B cells though going from mostly none at the beginning to various intermediate stages of activation to mostly fully activated later on. You can see there's several B cells that are intermediate activations continuing. And you can see also that the simulation is done over a lot of iterations. Moving on, we've still got our very simple network that is now not pie charts. It is, in fact, just circles, but they're colored in as they were before, and they're in a pentagonal network. Here, a red cell is labeled as node 3, and it says there's high demand on node 3. And you can see two graphics below, one of which is labeled disconnected network, and you can see that the red node, which was described as node 3, is now shown as a graphic where you can see it can only satisfy up to 40% of its requests because it has such a high demand. You can see that the other nodes are disconnected from it, so they can actually satisfy most of their requests because they have a lower demand. And you can see, because of the nature of the activation that goes on in the artificial immune system, there's fluctuation initially, but stabilization later on. Now, if this network was fully connected, you can see that the demand on node 3 is shared among the connected nodes, so that over time, after quite a bit of fluctuation initially, approximately all nodes are able to share requests at a level of about 60%, which for node 3 is better than before. But it does mean that the other nodes are also taking some of the demands. And imagine also that if a node collapsed in a connected network, because the node will be connected, the other nodes will be able to detect that that node had collapsed and take on its requests and thus deal with faults. So the use of artificial immune systems appear to be a particularly useful way of getting dynamic change in a network to respond to a set of scenarios. Now, that was a very biologically inspired use of change in a network, but another area that I worked on in telecommunications was not at all biologically inspired, and this was the use of recommender systems, the use of data science driving customer-oriented business decisions. And you see here two images from press releases prior to the solutions being developed. On the left-hand side, a press release suggesting that recommender systems could be used to provide recommendations to parents, ideally, to recommend video on demand that their children might like. On the right-hand side, you see an image from a press release suggesting that recommendation systems could be used to recommend what to look at on a mobile phone. But these days, we're very familiar with recommender systems every day, or at least we should be, because here we see the iPlayer, which I captured an image the other day, and the BBC iPlayer uses recommender systems to recommend what you should watch. And this is not at all surprising, because when I was working on recommender systems, I was working in collaboration with the BBC, as I will talk about in a moment. But where do the basis of recommender systems come from? Well, they come from the statistical basis of prediction in data science. There are many different techniques that can be used. The area that I found most useful, and certainly I know has been used in a lot of different solutions, but there are other techniques, is to use linear algebra to rank users or items according to predicted preferences. And my experience has been that this use of predictive modeling has been used to recommend in retail context and also to alert in the business context. Here is a diagram from a linear algebraic explanation. What you see as an example of non-negative matrix factorization. On the left-hand side, you see a matrix that compares the ratings provided by users, where the users are only given by letters, and they have provided ratings given only by numbers about their ratings for certain items, where the items themselves are also only given by letters. And because each user probably doesn't know about every item, and because every item probably hasn't been marketed to every user, there's a lot of cells that are empty. And in fact, in a realistic retail context, a lot more cells will be empty, and we'd probably be dealing with a more higher dimensional solution than what we're seeing here. But anyway, it works for higher dimensional than small two-dimensional matrices, such as you see here. What happens is, with non-negative matrix factorization, you factorize a matrix and you produce either smaller matrices for users and smaller matrices for items, or smaller vectors, that is to say, one-dimensional solutions for users and one-dimensional solutions for items. And one-dimensional solutions are very useful because they can enable you to rank, for instance, items according to user preferences. And the other advantage of this technique is you can go from an incomplete solution on the left-hand side to a more complete solution on the right-hand side, giving you indications about how to rank things so as to recommend them. And this was what we found was very useful in the MyMedia project, which I will talk about in the next slide. The MyMedia project involved a number of large companies, including my then employer BT, as well as one public broadcaster, the BBC, as I previously mentioned, and some smaller companies and universities and research organizations. This took place about 10 years ago, where we, in a software development project, designed a recommender system platform that could be deployed over a number of different contexts, carried out research about what the most effective recommender algorithm was to use, and also carried out field trials comparing recommender systems with the recommendations that professional marketeers could select to recommend to their customers. In these field trials, customers that consented to be involved were presented through an online interface recommendations, but they weren't told whether the recommendations they were viewing came from a algorithm recommender system solution or from the choices made by professional marketeers. So this allowed quantitative analysis of whether the recommender systems were more or less effective compared to the expertise of professional marketeers. And for several participants in these field trials, including BT and the BBC, this seemed to be the case, which led to the deployment in future generations of recommender products, of recommender algorithms. On the lower left-hand side, you see one of many publications that came out of that project. Now, if these images captured on the right-hand side seem rather old-fashioned, well, that is because this project took place some time ago, and the solutions used have now gone through a lot of different generations, many of which I have not been involved in. Following my work on that, I worked on recommender systems in another context, which was to work for the telecommunications company Ericsson. Unlike BT, my previous employer, Ericsson's customers are often other telecommunications companies, and I was working on a project focusing on Ericsson's products for mobile network operators, or MNOs. Network managers for MNOs need to detect and manage faults. My project clearly could not detect those faults before they became faults, but it could recommend potential faults according to their likelihood of turning into faults, and then highlight them to network managers in network management centers like the one shown on the right. And the idea was that this would be embedded in future products of Ericsson so that they could be improved. Now, since then, I've worked in universities in various different contexts, supporting companies from inside universities, and now I'm running my own company, Evolve IT, providing IT consultancy. You may well ask what I do. Well, you'll see in my previous career, I've given examples at the intersection of applied mathematics, especially probability and statistics, examples that have needed software development, examples that have needed domain expertise in a range of different areas. And many of you will have seen this Venn diagram that I'm showing on the right-hand side, which places data science at the center of this intersection of these areas. And many people will agree, especially the people who created this diagram, that this is why data science is of great commercial interest, as I do as well. It's also of very great importance because it's very easy to gather large amounts of data, which didn't used to be so easy. But I would like to raise some words of caution at this point, because data may be easy to gather, but it may include personal data, and it may include sensitive personal data as assessed by the data protection organisations in the UK and elsewhere. Thus, it's my opinion and the opinion of those organisations that such data should always be analysed appropriately according to its context, and if including sensitive personal data, access should be restricted to those who need it. There are great benefits from the analysis of personal or sensitive personal data, but also risks. And I suggest you look at this book shown on the right-hand side to gain a review of some of those issues. As a volunteer, rather than a commercial person profiteering from it, I'm working in collaboration with the UK NHS in the Analyst X community, which has been formed on the Future NHS collaboration platform by NHS X within the NHS, from the community addressing data and analytic support for understanding COVID-19. Well, we understand that COVID-19 has not gone away, but in carrying out this collaboration, we've become aware that there are a lot of techniques that can be applied not just to deal with the problems of COVID-19, but in other areas as well. And I'm acting as a champion to stimulate awareness discussion and engagement in the Analyst X area, because I believe it's very important not just to address the issues of COVID-19, but other areas as well. Many people, of course, who are working within the NHS and also with the NHS to use data analytics are using tools such as Python and R. So this is why there have been communities set up within the NHS to use Python. This is the NHS Python, so-called community, and the NHS R community, which are addressable through these URLs. And if you can't get access through these URLs or the previous one about Analyst X, I can put you in touch with people who can give you access. These communities all have accounts on Slack and GitHub. The Analyst X community has set up a machine learning challenge, which is addressable through this link here. And the challenge is also shown here. The highlight is in the original. It's an extraordinarily broad challenge, but one which could be very beneficial. It's open to both individuals and teams, both inside and outside the NHS, and there's still some deadline to submit an entry. So I recommend that if you're interested, you consider it. Another area which I'm very interested in, because I think it's very important and it refers back to my concerns about the use of data earlier on, is about the assessment of data-driven health decisions. Well, of course, clinicians have been making decisions based on data for a long time before computers were even available. But increasingly, they can be made using algorithms independently of what clinicians are doing, because clinicians have such a huge time pressure. And there are advantages of this because it enables clinicians to do other things. And for users of such algorithms, who may be patients, it may enable them to monitor their own condition in ways that they could not have done before. But there are also issues to do with, for instance, comparing clinical decisions and algorithm results, understanding what the algorithm is, understanding algorithm evaluation metrics, and involving all stakeholders, not just the ones I've named here. So I think algorithm assessment is very important. There's a lot of questions to consider. I'm not going to go through these because they're not complete. And indeed, if you'd like to look at a more comprehensive list, I suggest you look at the checklist that's been put together by a high-level expert group that the European Commission put together here, which is downloadable from this URL. And you can go through this checklist. And it isn't just about AI, it's about software algorithms in general. I think as a trained product manager, you should also consider what product management has been carried out to develop software products that have been deployed in digital solutions for healthcare or in the healthcare and social care sector. And can you ask the software developers about what they have done, and can they provide you with that information? Other things that I can support that may or may not be of interest to you. I've had a long track record of obtaining successful funding for bids through a range of different sources and possibly others. A few are shown here. If you'd like to look at some of my details on this, look at my ORCID record shown here. And getting towards the end, I've also been involved in a lot of collaboration, which may well be needed for your bids. And other organizations need new contracts. I can draw upon my wide network that I've acquired during my earlier career, and you can look at that through my LinkedIn profile to help organizations who need this. And one organization I'm working with in this context is shown on the right-hand side of this slide. So in conclusion, I've talked about a lot of things in these slides. I'm sure some of them have been explained inadequately. That's why there will be some time for questions coming up shortly. Because I'm working in IT consulting, I'm aware this is not a stationary field, and I keep on updating my skills. Society keeps on changing, as we have seen very much so. And that's why I put demands on healthcare, because many of my clients have been related to the healthcare sector, but I'm also aware that other clients may be less so related to the healthcare sector, because I'm aware that demands of business customers will change. I monitor the business environment all the time. So there are lots of ways to get in touch with me. I'm going to go rapidly forward to a large acknowledgement slide, which there will be insufficient time for everyone to read. But I just wanted to put that there to acknowledge that I have to acknowledge many people, because I've worked in so many different organizations. But I'm going to go back here and stop to allow questions. And I'm going to stop sharing so I can see the chat window and see whether people want to ask me questions.
Oh, thank you so much. That was very, very insightful, Paul. I was just checking this question. I haven't seen any questions so far, but I do have 2 or 3 questions, possibly 4 questions, if nobody else has any questions. So maybe I should ask the first one while people think about what they want to ask you. The first one is business entrepreneurship related. So it seems to me like, you had your first instinct from academia, you went to industry. In this case, you work for a large enterprise. I believe it was BT, for instance. And now you started your own company. You are now your own boss in a way. So my question is the difference, because you are experiencing industry in a different point of view. One through a large corporation, now as a founder. What's for you? How has it been? The differences between the two?
I think it's a very relevant question, and also a very relevant question for anybody in the audience who are thinking about whether to make that change. When I moved from academia into a large enterprise, I was basically told, here's your desk, here's your boss, this is what you should do. And it basically continued like that for a long time. Now, creating my own business, I had to have a vision of what my market was and what my services I could offer, or products. In this case, it's all services. And that was based on my view of my experience previously. And then I had to find out about the legal and financial requirements that I needed to set up a business. And this was very different from working in large enterprises, where if I wanted to set up a project, I had to go to senior managers and say, look, I think there's a case for this. Can you justify a project with this sort of millions? And it's a bit different in a smaller company. So I started by lending myself from my own savings money, going to an accountant and saying, can you incorporate a limited company for me? And I'm going to market it myself. And that was it. I was my own person. And then I went out searching for clients. What I would tell anybody now is, don't even start your own company until you've spent loads of time without a job doing intensive market research, which I didn't. I did market research on the job as a founder. Yeah,
this is interesting, because this segue question that I was about to ask, what would you recommend someone like a young graduate or an academic who's tired of academia and looking to jump into industry? I guess you already mentioned one of the things that they should do, which is to do like market research and these things. But I actually think maybe I will disagree a bit on that in a way. I would say you don't necessarily, for me at least, you don't necessarily need to know exactly where, I believe you can jump off without, obviously it depends on your circumstances, right? Maybe if you have a family and, you have other stuff, it's much more harder to take the risk, to take the leap of faith. But maybe I'll hand it for you to comment a bit, to add anything else.
I quite understand your challenge there, because I've seen how Zyku Group has gone from what seemed to me like quite a narrow focused organization to quite diverse now. My hope in setting up my business was that I would be able to diversify very quickly, but I've actually found that most of my clients have called on particular areas of the services that I deal with rather than everything that I could potentially offer, which is why I refer to market research. So I think it may depend on the skill sets of the founders, and indeed also possibly the fact that you're having more than one founder. I think that's potentially a great advantage because I am my own founder. While I have had the great assistance of being able to talk to a lot of people who have founded their own businesses, and you may know some of them from the Liverpool startup community yourself. All the time when I've been running the business, it has been me.
Yeah, no, that's a very interesting point you made. I certainly, I will make a confession. If I didn't have my co-founder Liam, I would probably be very reluctant into jumping to starting the company myself. But yeah, and now then I have a question. I will follow up about it. Is this the decision for you alone to go and start the company solo? Is it a self-conscious made decision, or is it because you could not find someone else to start a company with?
That was really because after my previous post in academia finished, I had this view that I was going to move to a permanent post in academia, and I was making lots and lots of applications, which are all very verbose. I don't know whether you've had the experience of trying it, and finding that none of them were successful. And I didn't want to spend the time sitting in front of this very desk, because of course this was during the height of the COVID-19 lockdown last year, just filling in application forms but not actually doing any job. So I decided that it was much more effective to start my own business as soon as possible, because then I couldn't reject my own application for a business. And because I knew from my own savings I had sufficient funds to at least keep the business running for some time to get it started. Does that answer your question?
Yes. No. It's a great points that you made. Yes. Indeed, it's never easier to, very easy to start a company, especially I guess when you are coming from academia to jumping into uncertainty. Nowadays people say it's very easy because, you have venture capitalists, ready to throw money at academics, who promise, to change the world, blah, 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 all these things. But still, it's not, it's to make that decision, that conscious decision. It's very hard. So kudos, thumbs up for you for taking this brave step, really.
I think some academics have been quite successful in being able to have part-time involvement in creation of companies. Of course, when my contract in academia finished, I didn't have any academic connection.
Yeah, which makes it a little bit even more challenging. I was just looking at the chat here to see. Come on, guys. Does anyone else have any other question? Let me see. I guess I will go to another follow-up question. I don't know how are you in terms of the time, whether you are okay if we at least go to the hour.
About 5 minutes late.
Yeah. So yeah, my other question is to do with your interesting work. Though you said the volunteer work you did with the NHS. How has it been your experience working with the NHS, especially in these emerging technology arena? NHS is not necessarily known for fast adoption. In fact, there is a joke. Someone says there are more pilots in NHS than in Heathrow, meaning that you can have a lot of pilot projects in NHS, but then to taking it from a pilot project to actually putting it into production, let alone to something commercial, is really like it's a massive endeavor.
Well, I can report that I've done a 2-hour training course on the nature of NHS procurement. And that was complicated. And that was only the first part of the course. I didn't follow it up. I can also report something I didn't give in the talk, which is when I was working at BT, I started a collaboration, or rather, my manager started a collaboration between BT and a local NHS hospital trust to study the anticipation of clinicians and nurses to future IT technology, which was then being rolled out. So this was, in effect, a user experience study, but without the technology. And the idea was when the technology came in and was actually deployed, we would follow this up. But in practice, the NHS Trust decided not to follow this up. So I was already collaborating with the NHS then, but it didn't get very far. But that did suggest that many NHS staff then were really cautious about poorly specified IT solutions. But what I've been doing through Analyst X and previously the COVID-19 support part of Future NHS was initially discussing with NHS and non-NHS staff about different statistical and other mathematical solutions that might be relevant, and also trying to involve other people from outside the NHS and outside my company in Future NHS and Analyst X, because I think they'd be interested in the problems that are raised. And in some cases, I've been successful. I'm still thinking about the best way to address the Analyst X machine learning challenge because it's so broad and so hard.
Yeah, actually, thank you for sharing that. The challenge. I will definitely share it with the community to see if people want to perhaps gather together, create a team, hackathon type of style, and then come up with a winning thing that we can maybe put forward or something. Yeah, but it's definitely
yes. I mean, my what is called relationship manager in the NHS, which is a bit bizarre because I'm not employed by the NHS, so why I'd have a relationship manager is puzzling, but I do have. I'm an Analyst X champion. Is trying to get me to form a team, but that's probably with other people in the Analyst X community who are already champions. But I haven't yet worked out who will be interested enough to do it.
Interesting. Another thing, let's see again if there is any chat on the thing. No one is asking question. I guess it has become a fireside chat between us. That's okay.
Do you know how many people joined?
Yeah. Another maybe a final one. I would the thing is more of like predicting your future and taking on the example that you gave. A very interesting use case, by the way, about the recommender system. The results between the professional marketeers versus the algorithm. Do you foresee a future in few years' time where you think sales and marketing functions will be completely obsolete in the sense of being outsourced to machines?
No, I don't think so, really, because while recommender systems are used so widely today, they're sometimes not as good at the very subtle aspects of professional marketeering, and that's why there's a lot of research both in the academic and industrial communities of recommender systems research, which goes massively further than what I was talking about. And I also deliberately kept it a bit simpler than what we were studying, because that would eat up the whole talk. Certainly, I know of some fairly major tech giants who've got big bodies of researchers in recommender systems, and some fairly major computer science departments in universities who have as well. The field is not over. In fact, ACM Rexus 21 is happening in Amsterdam, I think in the near future, but even as an online person, it's too expensive for me.
Yeah, no, absolutely. I think on that very positive note, I'll just check the thing. So someone is asking whether you could slide the references on the thing from the slides. I mean, if you can share them with me, I can distribute it to the attendees, the references. Maybe not all the slides,
yes.
Whichever way you feel comfortable sharing the resources.
Yes, I can do that.
Yeah.
Okay.
Okay.
This is a good time to draw it to a close.
Yes. So thank you so much for for taking your time to join us and share very insightful content with us. It was very interesting, and we hope to have you back again in the future, especially after this Analysis X project ends. Or at least part of it, you can maybe show up and share some insights about how did it go after the submissions.
Yes,
so
possibly.
Invitation open. Yeah. So to the rest, thank you so much for joining us. I hope you enjoyed the thing, the talk. And I will keep sending you a newsletter about the next few events that we are hosting. On Friday, I will have my lecture on topology. So those of you who are attending part of that, don't forget at 5 p.m. UK time, you have my session on where we start with the metric topology. So Paul, you want to say anything before we wrap up?
Well, I've no idea how many people have been watching this, but I hope you found it interesting. And I will convert my slides into a form that can be shared. And you'll find my contact details as well as the links and the references on them.
Yeah, sure. And I must add, just before we go, this I will upload the recording on our YouTube channel, so you can revisit again this wonderful talk by Paul. So Paul, again, thank you so much for taking your time to join us, and have a good day, and we see you next time, everyone.
Okay.
Bye for now.